Hi everyone, welcome back, and let's carry on with our advection sim here. So I have done a few sims and I've offset this noise on our source, and I've selected 3 of those over here. I've done a flipbook of just one of them just to show you the current state. So that's just the one sim. We still need to offset these in time to make sure we get our pulses. But here you can see that it's pretty linearly fading off based on the age of these particles, which I think was a lifespan of 1 or 1.5. So you could take this even further. You could have a variance in the life. You could apply a life attribute based on the color or something like that, so you would get a few tendrils that live for a bit longer. I haven't gone down that route. Depends how it looks in the render, whether it feels a bit strange that it's dissipating all at the same time or not, but that's definitely an option for you to play with. And there's so many things you could do with this kind of magical layer. Just another thing to note with this kind of technique here of just advecting points and rasterizing is pretty much 80% of the magic you'll see, especially in fantasy, is based off of something similar to this. So whether there's a character with like a flaming hand, some kind of magical blue flame on their hand or something like that, it's usually a very basic volume sim and then advected particles, which are then rasterized and rendered with emission. So both this and kind of what we did on the portal forms a lot of how magical setups are generally made. So it's very good to mess around quite a bit with volume sims and particle advection sims, particularly with making sure that your sources are interesting and you have the ability to kind of manipulate this geometry based on these sources. So obviously here, if we go back to this frame, you can see my volume sim was pretty full, but I have just small areas of pops in the source, and the result is that you get a shape that's a little bit more defined than the volume sim was. So something to keep in mind, and definitely if you're interested in doing a lot of magical style effects, this is absolutely one of the most key components to doing magic. In general, if a client or a director is asking for some kind of magical energy or anything, usually what they want to see is a rasterized volume based on advected particles. So I've been through that. I've got my 3 sims. I think I've got some random numbers in here, and those were the particular shapes I liked, and they looked very different from each other. So we can compare those quickly now. So those are the 3. This one's kind of cool because it's kind of flying out in that direction there. There was a huge mistake I made on the previous video. If I jump into the pop advection, the gradient volume advection here I set to, that should be 3rd. I set to the 3rd input, but I forgot to change the field. So I think at that time I had velocity in here. And it begs the question of why we were getting such a good result out of using velocity. So let me see if we can look at this quickly. Basically I had something like this, and if we switch that off and reset, so that's our fully point position update advection over there. And then I have a second advection which essentially is still using velocity. So here I've removed everything except density, but when I was doing it before I still had the velocity fields and doing the same thing. So I don't know why switching that on reset simulation, we were getting such an interesting result that kind of matched what we were looking for, when in actuality what we've done here is we should be generating a new field based on density, which contains the gradient field. So I can see here, now we're looking at just density, and here we see a different type of volume, and that's because it's a vector version of density that should contain our volume normal. And so what I should have done, which I'll do now, is change the field name here to density. And if I reset that, so it's different, but it's almost the same. So a bit confused as to why the velocity field was giving us the same result. Let's just quickly test this out. So here we have velocity, then we compute our gradient, but we maintain our velocity field. We run it through the pupnet, change this back to val. Okay. So it's different, but it's not that as different as I would expect, forcing the advect by volumes to actually use a gradient field. So maybe it's not doing quite the same thing, but the end result just happens to look similar to what I was after at the start. I have a suspicion that basically I'm overriding the updated position with a new position that has a less intense value on velocity. So that's it's kind of keeping the particles thinner because it's not forcing their position to update. So if that makes sense, if I increase the velocity scale here, we should expect it to get tighter in a way that when we were using velocity, it wasn't getting tighter. Yep, and it is. So you can see there, basically this all makes sense to me now. So basically what was happening is I forgot to change the field in here to density. So what we were doing is we were updating the position based on velocity in the first advect, which was giving us a very full point cloud. And then we were overriding that position with a low value of velocity using the velocity field, which was making the particles less advected essentially inside that volume. So it was a similar result, but that explains why increasing and decreasing the velocity scale wasn't behaving as predictably. And now that I'm making sure density is the field we're using, we can actually control how far these points are updated based on the gradient field. And you can see I'm making it much more thin and tight. So we're getting way more tendrils there. But as it just so happens, I only want a small amount of that gradient advection there. So something like that, which was still giving me the result I wanted. So just a bit of a strange, confusing situation there. But for future, keep in mind, the gradient really is for either pushing in or pushing out points based on the density of your volume. And if you're duplicating advection pops, just remember to point at the actual field you want. And now for me, this is making a lot of sense of both why that looked kind of similar before, and now we have the option of increasing that in a way that's much more predictable. So I hope that makes some sense, or it's clear to you guys. So that gives us what we want there. I've simmed out a few versions here. Just look at that again. And before I hit sim, I increased my point count to, it was 10 million. So there's quite a lot of points in here, which is good because the rasterize definitely relies on a pretty hefty point count to get a good looking volume. And like I said before, without the delete, We're not seeing a great example of the final resolution, but we're going to jump into some render tests now and see what we can do. So ultimately we do need to merge these together into our 3 pulses, but for now let's render just one to save time. And we'll try and get that into a finished render state with a geolight and motion blur and everything, and then we'll introduce the actual pulsing. So let me just save here. Okay, so let's start by just putting down a basic volume shader. So I'll put down our pyro. Let's switch on velocity blur, it's already on. Let's make our mantra. And we want to render EMP magic. We want everything else to be a matte. And in terms of lighting, we don't have a light yet. I don't think we even need a light because I do want to make this an emissive volume. So for now, let's just look at it with all lights on. And let's go half res, motion blur on. Yep, we'll just leave everything like that. I've got 0.1 in this volume step rate just to increase any volume renders. That goes for the dust and the shock volume as well. And let's just apply our material here. Okay, let's do a test render. So here what we're looking for is to make sure that the resolution and the general detail we're getting from that rasterized particle sim looks good. And then from our shader we just need a decent amount of density, or at least if we're not rendering diffuse volume, we need to make sure that our emissive volume looks good. So we'll handle that as well. So just looking at the alpha here, I think this is just a little bit too low res to properly judge. I'll leave that at 2 and just go for full res. Just going to switch off any limits here. So there is something there. It's taking a little while to render. So there's our rasterized points. So that's basically a volume being lit by everything in the scene at the moment. So it's just standard density. And it's quite dark by default. But we can see it a little bit better in the alpha here. We're getting some pretty nice detail. Some nice tendrils. And I keep using the word tendrils because in Magic, one of the defining sort of factors visually is an unnatural smoky feel, in terms of the smoke wisps tend to want to link together in some kind of more of a surface tension type of way, where you get strands, essentially strands of energy that link together. So that gradient workflow is actually quite important in achieving that kind of look. Alright, so we're left with something like that, which actually looks pretty cool. Let's go back down, because I'm pretty happy with the resolution and general density here. Let's drop this back down, let's say 2/3. That's all fine. And mess around with the shader a little bit and see what we can get here. So here's our shader. Just going to bump this up quick in our color. Right, so here's the question. Do we actually want to render a density in the scene, or can we get away with just using an emissive volume? And I think for render time's sake, we could try that, or it might even look better if it has actual emission. So I'm going to go right here into the intensity field, and instead of heat we can just use density, as long as we spell it correctly. And now that we've defined our fire intensity field, I can choose temp. Oh, okay, so we might need, I'm not sure now whether this is taking the field I've just set here, or whether I actually need a temperature field. Mapping temperature to color. Let's test it out. I'm not seeing anything. I think just to be sure that we're using the shader the way it's expected is I'm going to take our final density over here, just put down a name sop, and we'll take density and we'll call it temperature. And we'll merge it back on. Please don't crash. Okay, I'm just going to give this a few seconds and see if it catches up. So now we should have a density and a temperature field at least, even though they're based off of the same thing, just to make sure that everything the shader is looking for we have. So I should change our fire intensity. Oh, yeah, so it's immediately working. So I think it really is looking for a temperature field, instead of defining that value based on whatever we plug into the field over here, unless I've done something else wrong. So temperature. Drop that back down to default. Okay, so now this is our emissive volume. So we still have our density, but this is completely now emissive and irrelevant in terms of the scene lighting. And we can just fit that. We can fit that field, which is basically density, and see if we can get any variation in highlights versus the dark saturated colors. So it's all a little bit abstract right now because we're looking at such a low quality render. But basically I want something not too intense. We're going to add glows and all kinds of things in comp, so we just need a very clean render with range. So as long as we have some hotspots. There's something else I was thinking of doing as well. Ah, yes, because we need to add velocity. So at the moment we've got no motion blur here. So that looks pretty nice. A very basic shader. Let's take our points, and because we're using update position final velocity, you can't trust that as an actual representation of velocity through this effect here. So we will need to put down a trail, which reminds me of the other thing I changed, is I plugged in the same switch from our volume source to the null into our particle sim, but I switched that off after 1 frame. So basically this particle simulation is based on 1 frame of points entering into that sim. So to avoid this overfilling this volume with points, the points basically just shoot out once on 1 frame and they get advected. So I'm a little bit scared to try and visualize this velocity with this amount of points. So I'm just going to not do that and hope for the best here. So we want to compute velocity on every single one of those points. Okay, that was a big giant crash I just had. It didn't save a backup file, nothing, it just crashed, just shut down. So luckily I had saved pretty recently. And I've just put down that trail again, and I'm not looking at it just in case, but basically here we are computing velocity, and we can change how much our motion blur is affected by changing our velocity attribute over here. So basic emission shader. One thing I want to do before we pick up the test rendering again is just take off our candidate lights. Now that we have the emissive volume working, we don't need the lights to affect the diffuse at all. Okay. So let's see how this looks. We can't compare immediately here with the previous unmotion blurred one because I just want to add that trail and get that done with. But we should be able to see if the points feel, or if the volume feels like it has a decent amount of blur. So we want something to imply that sense of motion on it. And as you can see, this is rendering much quicker now without the lights in our objects here. Okay, let me choose a frame just after the start. So let's go down here where it's a little bit more extreme in its motion. See if that motion blur is picking up or not. I like the range we're getting over here. Looks pretty good. We've got some nice little hot pockets. In terms of motion blur, I'm not seeing too much. Let's compare this now when we switch off geometry velocity. No, nothing. Okay. So obviously I've completely forgotten about turning this velocity into a volume. So the way I usually do that, I don't know why I was expecting this to just start blurring. Let me pause that. Actually, we need to look at these points now. Is I put down a VDB from points, VDB from particles, let's just go a little bit higher here, a little bit lower here, just to avoid a crash. So I can generate a VDB independent of our rasterizing over here and choose values that feel good. In terms of distance, the velocity field doesn't need to match 100% the density field we have underneath, but we want the velocity field to cover everywhere the density is. So it doesn't need to be high resolution or anything like that, but the closer we can get it to covering the density without affecting our computational time here, then the better. So say we go with something like that. Then I can switch this off and come down to the bottom of our VDB from particles and just add a point attribute here. And choose V, and then just set this to val. So this is actually now visualizing the velocity attribute as a density here in the scene. So I can just put down a volume visualize if I want to not see that, and just merge that together with the rest of our fields. So this is our temperature, our density, and our velocity fields. And I'm pretty confident that our velocity is covering our density field, so that should be fine. So now let's try this again. And now we're talking. There we go. So there's a pretty good looking motion blur. I think we can go a little bit less. We still want to have some readability in the detail here, because it's a pretty high detail, high frequency, thin type of effect layer. So we don't want to completely blur that into non-existence. So I can just half the velocity scale on our point cloud. And that will be us. So the next thing we need to do once we check this render is merge these three layers together in a way that replicates our pulsing. So just a bit less. So something like that should do. So now let me cancel that, and let's try and get our spherical animation in there as well. I think what I'll do is, just to see that the pulsing is working for this effect, is just do a flipbook of the particles again. Right, so I'm just going to take our sphere anim, and we do need to do that here, I guess. We actually need to apply this trail on every single one of these independently. If we merge them all together and then do a trail, there might be some issues there, because we have different points merged together with potentially the same IDs, stuff like that. So I'll just trail them each separately, and then we can merge them. And just so that I can flipbook this stuff, I'm going to switch off that as an extra computation that we don't need. Right, so now we have all of these, and we have our sphere anim. So what's the best way? I think we shouldn't merge them, actually. I think we should have some 1, some 2, and some 3 here in the subnet. And then if we jump inside, I've got this alpha and transform, which we don't need. We're just trying to time shift this stuff. So basically, our first simulation will play at the time we've simmed it, so from frame 174. And then our second sim will play 23 frames behind that, and then our last particle sim will play after that. And we just merge that all together. So let's try and do a flipbook of this and see if that works. And I'm going to visualize our shockwaves as well. So unfortunately, when you're working with such a high density point cloud, it does really make a difference how dense it is. And in terms of especially rasterizing and making a sort of high detail volume, you need a lot of points. And so depending on the machine you're working on, that could probably be a potential issue for just managing all of that point cloud. So far my machine seems to be handling it okay. But I think if I was working on a full-on production, I would have way more points than even I have here. So something to watch out for. Okay, so now technically by the time this reaches the frame that our second blue sphere appears, we should see our second particle sim. And I'm kind of hoping there's not much left over from the previous particle sim. So we need to see that our fade off time is kind of working as well. It will be a little bit hard to judge that though, just looking at these points. But hopefully we get a good sense of the timing overall. I forget which frame it's going to appear on. And just like the portal, you can then take this sim and actually do a bunch of stuff after the sim, just in SOPs, so some twists or magnets like we've done before, or use the environment SDF and use that wrangle to kind of push it up or down in any direction. So loads you could still do to make this even more magical. For me, kind of the especially with this kind of expansive one, the less you do it, obviously the more natural it's going to feel. So it depends if you're after a natural magical effect or something that feels more designed, which would be, I guess, more the sci-fi stuff. But it's covering quite a lot of space, which I think is good. It gives us a chance to see the pretty cool collision it's having on the ground. So if we set up a geometry light as well, we should get some nice ground interaction there. I just really want to see enough here to see the second one. It's taking a long time to flipbook though. So I think that's the second one coming past. I think I might just pause this recording here and let this carry on. So I'll see you in a few minutes. Okay, I'm back, and this was a little bit of a waste of time. I can hardly tell if the timing's working. I've just tried to do it again without the sphere and just using points, but because I've got an alpha attribute, it's kind of starts to make a bit of a mess once the second sim appears, because the alpha of the first sim is affecting the look of the second one. So almost impossible to tell what's going on here. I think the best thing to do at this point is probably just to render this out, and we can take a look at it in the comp. It actually renders very quickly, so it's probably worth doing that instead of messing around with trying to visualize this huge point cloud. So I'm just going to stop that there. Let's just have a quick recap of this part of the effect before we get set up to light and render everything. So on the subject of lighting, we've already got a light from our surface, we've got a light from our electricity, and now we'll have a light from the magic as well. So before I do anything, let me plug in our merged sims into here and into here, and re-enable our trails. Okay, so that should be us good to go for the magic. Nothing else to clean up, I don't think, at this point. Let's see what we can use as a light. I think we could just take the final renderable over here and do a volume light. So let's see how this works. One problem with volume lights is the samples can get a bit tricky to deal with. The volume obviously naturally has a lot of sampling situations because it has varying densities, so it has to sample the light for each different density as well. So I just put geometry, I believe, and then I point this to our object. So I want our render, and then that's going to load the density or all our fields actually into this light, which means if I want the same effect that I'm getting in the render from the light, I need to also have the material. So I'm going to put the material in the light as well. So that's our volume material. Let's set up a basic active radius here. Okay, and disable that, and then I think I'm going to add this to our main environment render. So we have candidate all, and then I'll force it there. So let's have a look. Let's choose a frame and see what the environment render looks like quickly, and then I'll add in that new light. Make sure that's working fine, and then the only thing left from there is to render everything out. So there's quite a few layers here we need to render out. Probably take at least overnight, if not maybe 2 days. We'll see how that goes. With any luck, once we're comping, we're happy with the amount of elements we have to build this effect up, and so that will mean all our rendering is complete once these have been rendered. Okay, so this is our environment render. And if I now include the magic light, could be a bit more descriptive with that one. Okay, first things first, let me just come back here and switch off indirect contributions. So I am seeing something over there. There's something. So I'm just playing with this now to get something. If I do include this in the environment pass or as a separate pass, obviously I'm putting a lot more stock in it if it's part of the environment pass. So it's not going to be a crazy over-the-top light. It's definitely not going to be the most important light in the scene. And the likelihood is it's going to be covered up by all of our other lighting from our other environment passes. But what I do want is just to make sure that there's some kind of contact light. So anytime this magic gets close to the ground or the cars or whatever, we actually see a response from the environment. So I'm just going to check another frame. This is definitely one of the heavier passes to load up into the renderer. Okay, that actually looks pretty decent to me. We have a very definite reaction here on the environment from that volume light. Other thing you could do is, like we've done before, is just use a VDB to generate a polygon mesh from those particles instead of using a volume light, which is slightly heavier in terms of samples usually, because you're using a material that has a density. But does tend to give a very nice fall off in a way that you wouldn't really get with a geometry light. So that looks pretty good. I think let's stick with that, and let's go ahead and render out each one of these. So in the end we'll have the surface, we'll have the internal fog, we'll have the electricity, we'll have the reaction dust, and we'll have this internal magical element. Not to mention, we'll have a new light on our environment pass, and we'll have a light from our surface onto the environment, and a light from our electricity onto the environment. So plenty there to get rendering. I'll go through and make sure my settings are of a decent quality as well. So for some of these passes, probably want full resolution, some higher pixel samples, and those are for the cheaper ones, so I need to do some renders to check render times. But for sure the dust pass and the shock volume, I might have to go with the lower resolution and maximum pixel samples of 3, I'm guessing. So I'll just check those render times, see what I'm comfortable with in terms of the final settings. And in the next video, I think we'll be jumping into the comp to try and bring all of this together. So I'll see you guys then.